Welcome to Noble Hope Academy. It's new teacher again, Dennis Obongi. Today we shall be looking at periodicity of physical properties. It is actually a continuation of the previous lesson where we looked at atomic radius. So if you need to watch that video, please go and watch the previous video. It is a continuation. Today we shall be looking at melting point. So what is melting point? Melting point is a fixed temperature at which a solid changes into a liquid. For example, melting point across period 3 elements. So if we are taking the period 3 elements, that is sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon, we realize that the melting point will vary according to the structure in those molecules, and the structure comes in on how they bond. So in sodium, magnesium, and aluminium, the bonding there is metallic bonding. So the structure that we get from here is giant metallic structure. Then in silicon, the bonding is covalent, but many atoms are strongly covalent to each other, so we get giant covalent structure. In phosphorus, sulfur, chlorine, the molecules bond covalently and will give us simple molecular structure. So we realize that we have higher melting point on sodium, magnesium, and aluminium, because here we have metallic bonding. And what determines the strength of the metallic bond? It is the number of electrons that each of these atoms are contributing to the sea of delocalized electron. Take for example sodium. Sodium contributes one electron to the sea of delocalized electron, so as to form sodium ions. Then magnesium contributes 2 electrons to the sea of delocalized electrons. Aluminium contributes 3 electrons to the sea of delocalized electrons. So the delocalized electrons have to be attracted to the positive charges, or which also increase in the number of the positive charge would also affect the strength of the metallic bond. The delocalized electrons in sodium, they have the electrostatic forces of attraction, which is lower than that of magnesium, and even the one of magnesium is also lower than the one of aluminium. Because if you check here, we have 1 plus, here we have 2 plus, then here we have 3 plus. So this one makes aluminium to have a greater metallic bonding compared to magnesium and sodium. But the general structure there is giant metallic. When you come to silicon has the atoms in the molecule strongly bonded to each other by covalent bonds. So many atoms of silicon form now what we call a giant covalent structure. So comparing the melting point of sodium, magnesium, and aluminium, silicon has the highest melting point because the molecules have a giant covalent structure. Then, lastly, the molecules of phosphorus, sulfur, and chlorine, they bond to each other by also covalent bonds. But in this case, they form simple molecular structure because the covalent bonds in these molecules are weak. They are not stronger like the ones in silicon. So to wind up, you have to know that for any melting point, if you are describing melting point, across a period, the melting point increases. That is, across period 3, increases from sodium to aluminium. Then it is abnormally high in silicon, and it decreases so fast. Actually, it is very low from now phosphorus to going to chlorine. The melting point is very low. So the reason being, or the difference in the bonding. This one here is metallic bonding. Here we have covalent bonding, but we have many atoms covalently bonded to each other, forming a giant covalent structure. And here we have simple molecules with weak covalent bonds. Thank you for watching this video.